Good morning, students. Today we are going to study about the Bohrs model of atom. Okay. The last class we studied about Rutherford model of atom. Today we are going to learn about Bohrs model of atoms, isn't it? So the last class what we studied, discovery of nucleus. Who discovered nucleus? Do you remember? Rutherford. Isn't it? Through a gold foil experiment, he discovered the presence of nucleus in the atom. Isn't it? So nucleus was discovered by whom? The last class we studied, isn't it? The nucleus was discovered by Rutherford. Okay, and Rutherford said the last class I taught the limitations of the Rutherford model of atom, isn't it? The limitation, what limitation we studied? He said he failed to explain the stability of atom, isn't it? So he failed to explain the stability of atom. According to him, the nucleus is present at the center, proton and neutron, surrounded by electrons, and these electrons circulate like a solar system. These electrons revolve around the nucleus. In which fashion? For example, this is nucleus means if it is an electron, it moves up and down. Okay. So at one point of level, this electron lose energy. If it lose energy, it will fall on the nucleus. Since the stability of the atom will not be possible, isn't it? Stability will not be there. But already the theory says that atoms are stable. Okay, students. So the last class we studied about the discovery of nucleus by Rutherford through gold foil experiment. Okay. In that, one limitation also there. So the drawback or demerits of his explanation is about the stability of atom. Okay, according to him, the electron revolve around the nucleus in such a circular path. At one point of view, this electron will what? According to electromagnetic theory, if the electron circulates in such a fashion, at one point of view, it will lose energy. If it loses energy, what happens? It falls on the center of the nucleus. Hence, the atom will lose the stability. But our theory says that atoms are stability. So, the stability of the atom was proved by the next scientist called as Niels Bohr. What's the scientist name? Niels Bohr. So, this drawback was explained by the next scientist, that is Niels Bohr. Niels Bohr in the year 1913. Niels Bohr in the year 1913 postulated a theory under heading called as what? Bohr's model of atom, and he explained the stability of the atom. Shall we see? So, Bohr's model of atom. The full form of this author name is Niels Bohr. Hence only it is also called as Bohr model of atom. In the year 1913, he postulated this theory. Okay. So according to him, atoms. Okay. According to things, atoms revolve around the nucleus only in stationary circular path. Okay. According to Niels Bohr, the electrons revolve around the nucleus only in stationary circular path. Okay, and this path is called as orbit. The path in which this electron rotates is called as what? Orbit, or you can call it as shell, or you can call that by energy. So, in Bohr's model of atom, the first theory explains what means the atom, the electrons revolve around the nucleus only in stationary circular path. They remain in the same orbit. Like the what? Whose theory? Rutherford model. It does not move up and down. Only it will rotate in the stationary path. For example, if this is the electron, this electron only circulates in this path. In this path only this electron always circulates. It does not move up and down. Okay. So according to Bohr, the electrons revolve around the nucleus only in stationary same circular path. And the path in which this electron rotates, the path is called as orbit, or you can name the path as shell or energy levels. Do you understood the first point? So say electrons revolve around the nucleus in stationary circular path, and the path is called as what? Orbit, shell or energy level. This is the first point. You understood? So it does not move in such a fashion. Only this electron will rotate in this orbit. Okay. Since they are rotating in the same path, see, if it moves from up and down only, it will lose what? Energy and it falls. Since it is moving in the same path, it does not lose energy or it does not gain energy. So it does not lose energy or it does not gain energy. Since electrons are revolving in the same path, this electron does not lose energy and it does not gain energy. So there is no possibility of falling of electrons on the nucleus. Hence the atom will be what? Stable. Okay. Then second point what? As the electron is moving in the same path, they does not lose energy as well as they does not gain energy. Hence the electrons does not fall on the nucleus. This is the explanation given by whom? Neil Bohrs. Okay. The first point, it rotates in the same path. The name of the path is orbit, shell or energy level. The second point, since it is moving on the same path, it does not lose energy as well as it does not gain energy. Okay. The next one, third point. See, when an electron, okay, receives the energy from outside, for example, this is the electron, okay, or an atom. When an atom absorbs external energy, it from ground state, you can consider this as a ground state, it will move to the excited state. So when an atom absorbs the energy, the electrons present in the atom jump from one energy level towards the next energy level. After a few minutes, when they lose energy, so when they get from lower energy level, when the electron gain energy from the ground state, it will move to the next energy level, that is higher energy level, that is called as excited state. And when they lose the energy, again it comes to ground state. Again it comes to what? Ground state. This only happens when they observe the external energy. Otherwise, they will always circulate in the stationary circular path. Okay, first point I hope you understood. Second point you understood. The third point, what means this will not happen often. When an atom gains energy, when the atom is exposed to energy level, then the electron absorbs the energy, then from the ground state due to the external energy. Okay, when I am standing here, when someone pushed me from one state, I move little forward, isn't it? After that, I will come again to my original position. Due to the force which is applied on me, from one position I am jumping to the next position. Like that, here also the atoms, when they absorb the energy due to the energy source, these electrons from the ground state, little they get excited to the next level energy. After they are losing the energy, again they come to the ground state and in the same path they will circulate. That one will be understood. When they absorb the energies, they jump from lower energy level to higher energy level. When they lose energy, again they return back to the lower energy level. That is, from the ground state, due to the absorption of energy, they will jump to the excited state. When they lose it, it comes to its original position and they circulate in the same path. Okay. Have you understood? Next one is the fourth point. So first point, stationary circular path. Second point, they does not lose or gain energy since they are moving in the same path. And there is one more possibility, when the atom absorbs the energy, there is a possibility of jumping of electron from one energy level to the next energy level. When they lose the energy, again it comes back to its original position and they circulate in the same path. Okay. And the fourth point, see, Neil Bohrs named each orbit, he has given alphabet names. Okay. For example, this is the nucleus. The first shell or the first orbit near to the nucleus, the first orbit near to the nucleus is called this. He named it as K shell. What is the name of the first orbit? K. The next, L, M, N, and so on. Okay, and so on. Okay, so he named the orbit of an atom as alphabetic name. Okay, what are the name? What is the letter he has given? K, L, M, N, and so on. Okay, so each orbit he named or he given alphabetic number. Alphabets, what are the alphabets used here? K, L, M, N. Or the number wise means quantum number. We can say quantum number, energy level. Quantum number means what? Quantum number means energy level. So according to quantum number, he given n is equal to 1, 2, 3, 4 and so on. Here K, first orbit name K, the energy level n is equal to 1. Here L, energy level is 2. Here 3, 4, the last orbit 4 and it is over. Okay, so Niels Bohr named the each orbit as K orbit, L orbit, M orbit and N orbit and so on. And the number has quantum number. We can say in this word quantum number. The energy level in each orbit is fixed to 1. Okay, each orbit has its own energy level. With the same energy level only, the electrons moves in the orbit. So energy level n is equal to 1, n is equal to 2, n is equal to 3 and n is equal to 4. And the maximum number of electrons that can be accommodated in each orbit was given by the formula 2n square. Okay, the maximum number of electrons that can be accommodated in each orbit was given by the formula 2n square. Have you understood, students? So first one, this is the fourth point. First one, stationary circular path. Next one, never lose or gain energy. Next one, when they absorb energy, they will be excited. Here, fourth point, Niels Bohr named each orbit. Alphabetic wise, K, L, first shell is or first orbit K, second orbit L, third orbit M, and fourth orbit N. Energy level n is equal to 1, 2, 3, 4, and so on. And each number in one orbit, how many electrons can be placed? In one orbit, how many electrons can go to? Just given by the formula, the maximum number of electrons. Okay, this is for what? Maximum number of electrons in an orbit. The maximum number of electrons in an orbit is given by the formula 2n square. Is given by the formula what? 2n square. Okay. So the first orbit name what? K. First orbit name which is nearest to the nucleus. The first orbit name is what? K. So according to the formula 2n square. Energy level n is equal to what? 1. Energy level is equal to what? 1. So substitute 2 into 1 square is equal to what? 2. So the number of electrons that can be accommodated in K orbit. K orbit can hold maximum how many number of electrons means 2. According to him, the maximum number of electrons that can be placed in the K shell is 2. Then next orbit name what? Second orbit name L. So n is equal to what? M is equal to 2. So 2 into 2 square. So 8. So the number of electrons that can be accommodated in L orbit is 8, like that. So on, we substitute for M 16 and N, the total number of electrons is 32. So K orbit can hold the total number is 2 electrons, L orbit can hold 8 electrons, and M can hold 16, N can hold 32. According to him, the number of electrons present in each orbit is 2, 8, 16, 32 and it goes on. Okay. So the maximum number of electrons in an orbit is given by the formula 2n square. Here n is the quantum number or energy level. The first case the energy level is equal to 1. So 2n square. So total number of electrons can be 2. Here 8. The last one 16 and 32. Okay. So the number of electrons was given by the formula what? 2n square. Okay. This is the fifth point, the total number of electrons. So, what are the shells? K, L, M, N. So, number of electrons 2, 8, 16 and here 32. Okay. And the nucleus K, L, M, N. When we move away from the nucleus, the energy level goes on increasing. When we move away from the nucleus to the last orbit, the energy level goes on increasing. When we move energy level goes on decreasing. Okay, when we move away from comparing to K shell, L shell has more energy level, M has more, like that. Energy level goes on increasing from K orbit to N orbit. When we move from N to K orbit, again reverse, energy level goes on decreasing. So the number of electrons that is near to the K orbit is called as K electrons. Here the electrons present in L are L electrons, M electrons, N electrons. And which is nearest to the N has what? Lower energy level, which has the electrons that present in as what? Higher energy levels. Okay, this is about what? Neil Bohr's model of atom. So according to him, he proved the stability. How he proved? He said that it does not move up and down. It only circulates in the same path, and the path is called as orbit, what? Shell or energy levels. Okay, since they are moving in same path, there is no need of losing energy or gaining energy. With the same energy level, they rotate. Each shell has the amount, the fixed quantum level. Okay, each orbit has their own fixed amount of energy levels. Okay, with the same energy level it moves. But when an atom is exposed to higher energy levels or like any external energy source, when it absorbs the energy source, due to the absorption, electrons present in that atom will get an excited state. From the ground state, it will be excited. After losing energy, again they come to the same circular path or same orbit. Okay, and each orbit is named as what? K, L, M, N. And number wise, if we quantum number means 1, 2, 3, 4 and goes on. Okay, so a number of electrons that can be present in each orbit was given by the formula 2n square. Don't forget, the formula is 2n square. Okay, n is the number of, that is quantum number, energy level. So according to that, 2, 8, 16, 32. And this theory also has what? What we can say, limitation or drawback. What drawback means? This theory, this system or this postulates only applicable for smaller atoms, the atoms with a less number of electrons. It does not, okay, uranium, isn't it? More electrons are present in uranium, okay. So it is not applicable for what? Multi-electrons containing atom. It is only applicable for small electrons, small atoms like that, hydrogen, helium, lithium, beryllium, etc. Okay, this theory only applicable for hydrogen, helium, lithium, beryllium, etc. Only the atom with less number of electrons. It is not applicable for atom with the multi-electrons, uranium. This may contain what? Many electrons, isn't it? Okay. So what? Uranium. Okay, so it does not, 92 electrons are there in uranium. So for that it is not applicable, and he failed to explain the total number of how these electrons will accommodate. 92 electrons, how they will get accommodated in an atom. He failed to explain because this K shells contain so many subshells. This orbit contains subshells like what? S, P, D, F. Okay. So, based on this only, the number of electrons is placed inside the subshells. He failed to explain how it is applicable for multi-electrons. Did you understood? Okay, up to 32 is there, isn't it? Total number of electrons, and it goes on. And how these electrons are placed inside the shell, he did not explain. And it is only applicable for the atom with the less number of electrons like hydrogen, helium, lithium, beryllium, boron, etc. It is not applicable for higher electron content of multi-electrons containing atom like uranium, etc. Okay. So this is the limitations of Bohr's model of atoms. Okay, you have one book back question for this. So I hope you understood. One book back question is there. Take evolution part. In the evolution part it is given. So here it is there. Please students. Here it is that explain the postulates of Bohr atomic model. Important question, okay. Roman number 8, second question. The answer is on the page number 127. Roman number 8, second question. Explain the postulates of Bohr atomic model. Explain the postulates of Bohr atomic model. The answer is on the page number 127. Okay, here. Up to this much. From here to here. Okay. Mark the question. Roman number 8, second question. Now we can see the discovery of neutrons. So So already we studied about what? Discovery of nucleus, next discovery of neutrons. Already Rutherford predicted there must be one more compound inside the nucleus. One already what he discovered? Proton, that is one presence of positive charge. And he named it as what? Nucleus. At that itself he predicted that the presence of one more compound or one more component inside the nucleus. But he did not name it. It was proved by, in the year 1932, it was proved by the scientist James Chadwick. Okay, it was proved by the scientist James Chadwick. Okay, so discovery of neutrons in the year 1932. Presence of neutrons inside the nucleus, it was discovered by what? James Chadwick. Where these neutrons are present? Inside the nucleus, in the proton and neutron. Under itself I said, what is the main role for the presence of neutron inside the nucleus means it will prevent what? Repulsion. It will prevent what? Repulsion. We know that two positive charge will not attract each other. We cannot place, okay, together. Okay, two proton plus proton you cannot keep together because same charge. What? It will repel. So in order to prevent the repulsion, in between what is there? Neutrons are placed inside the nucleus to prevent the repulsion between proton and proton. Okay. Here what he did, James Chadwick, means he took beryllium atom and he exposed to alpha rays. He exposed to what? Alpha rays. When the heavy bombardment between beryllium and alpha rays were passed or it reacted with beryllium, he found that a few particles were exposed outside. Okay, few particles from beryllium was exposed outside and it was detected by detector. Okay, so beryllium was exposed to alpha rays. At that time he found that few particles are ejected outside. Okay, that is called as neutron, and it was measured by detector. In detector it does not show any charge, positive or negative. Okay, from this concluded that neutron does not contain any charge, but they have considerable mass. Okay, so discovery of neutrons in the year 1932, the scientist James Chadwick discovered what? Neutrons. How he discovered this? He bombarded beryllium with alpha rays and he saw that some particles were ejected from beryllium and it was catch or detected by using a detector. Okay, in the detector he found that the particle that come out from the neutron has equal mass to that of proton. I already said that for an atom which one contributes mass? Proton and neutron. So the particle that ejected from the beryllium also has equal mass considering to that of the proton, but it does not carry any charge. So from this concluded that inside the nucleus along with the proton a neutral charge particle also present, that is called as neutron, and it has considerable mass like that of proton. A proton. And he named, since it does not have any charge, neutral, he named it as what? Neutron. Okay, so here I mentioned like this, isn't it? This indicates the mass number and this indicates the charge. This indicates what? Mass number, and this indicates charge. Okay, they have considerable mass number like that of proton and it does not have any charge. Hence it was named as what? Neutron. Okay, so the next class we will study about the subatomic particles of